Even in the pandemic year of 2020, India's import bill for crude oil and other petroleum products like aviation fuel was over $100 billion, which is more than 25% of India's total imports. This staggering figure will continue to grow unless alternative fuel sources are found or generated. The Government of India has a multi-pronged strategy to reduce imports by increasing indigenous production of biofuels to the Indian energy basket, like blending ethanol to petroleum by 20% and biodiesel to diesel by 5%. Multiple initiatives to increase indigenous productions of biofuels have been taken up. We travelled to Dehradun, Uttrakhand to visit the Council for Scientific and Industrial Research, or CSIR's Indian Institute of Petroleum, for a first-hand look at the kind of research and innovations taking place in the biofuel sector. In this episode of Science for a Self-Reliant India, we take a close look at two crucial technologies from renewable sources and environmentally sustainable ones for producing biodiesel and the indigenously developed biojet fuel process for aircrafts. We also explore the technology developed and tested at IIP to generate helium gas, which India imports in large quantities. Helium is crucial for many manufacturing purposes and products. All these steps are part of the larger vision to strengthen India's economy and create jobs by leveraging science and technology. So let's begin our program, Science for a Self-Reliant India. The Indian Institute of Petroleum, IIP, was established in 1960 and is one of the integral laboratories of the Council of Scientific and Industrial Research, CSIR, and dedicated to research and development in the hydrocarbon sector as well as alternative energy such as biofuels from waste oils, discarded plastic and biomass-derived feedstock. IIP not only develops processes and products for petroleum refining and petrochemical industries, it is also an important institute for training of personnel for the oil and petrochemical industries, assisting in formulation of standards for petroleum products, but also actively exploring alternative sources of energy such as biofuels. A thrust area of research for IIPM Dehradun scientists and engineers is to develop indigenous technologies and processes to create biodiesel, which has applications in the road transport sector, the railways, as well as developing biojet aviation fuel for aircrafts.
We import roughly 350 million tons of carbon atoms for fuel every year. And you know how much we throw away as a country? We throw away more than 500 million tons. So if we just learn to collect all our waste streams which contain carbon and deploy them into fuel or use them as alternatives to fuel, we will make a huge change. So India imports also 20 million tons plus of cooking oil every year. And even if we could capture 20% of that, 4 million tons, that would supply the entire diesel demand of the railways and the armed forces. So across the country, there is a movement led by Food Safety Standards Authority of India, FSSAI, and the Ministry of Petroleum and Natural Gas called RUCO, Repurpose Used Cooking Oil. As part of that, used cooking oil from halwais, restaurants, big shops, canteens, everywhere it's being collected and being converted to biofuel. You can turn it into biodiesel, you can turn it into biojet fuel, or you can also turn it into something called green diesel, which is exactly like fossil diesel, but is made from used cooking oils.
So what is biofuel? Well, it's a fuel derived from biomass, that is, plant or animal waste, and sometimes from microorganisms also. Since such biofuel can be replenished easily, biofuels are considered to be renewable sources of energy. Biofuels are considered as a cost-effective and environmentally benign alternative to petroleum and other fossil fuels. particularly in the context of rising petroleum prices and increased concern over the contribution of fossil fuels to global warming. Some common examples of biofuels include ethanol, biodiesel, green diesel, and biogas. Biodiesel is a very important biofuel given its application in the transport sector, power generation, large motors, and industrial machinery. Indian Railways is the largest user of diesel, about 2 million metric tons per annum. Biodiesel is the name given to a variety of ester-based oxygenated fuels derived from natural or renewable biological sources such as vegetable oils. Biodiesel fuel can be made from new or used vegetable oils and from animal fats. Unlike diesel derived from petroleum, pure biodiesel is biodegradable, non-toxic, and essentially free of sulfur and most other pollutants. Biodiesel doesn't require any special engine modifications, as it operates in compression ignition engines like petroleum or diesel ones. The concept of using vegetable oil as a fuel dates back to 1895, when Dr. Rudolf Diesel, after whom the fuel diesel is named, developed the first diesel engine to run on vegetable oil. Biodiesel forms an important component of India's biofuel policy. India is looking to tap the potential of this essential source of renewable energy and subsequently increase its share in the domestic energy market. Our country has great potential for production of biofuels such as biodiesel from non-edible oil seeds. India grows around 100 varieties of oil seeds and only about 10 to 12 varieties have been tapped so far. The annual estimated potential is about 20 million tons. Wild crops cultivated in the wasteland also form a source of biodiesel production in India. And according to the Economic Survey of the Government of India, out of the cultivated land area, about 175 million hectares are classified as waste and degraded land, which can be used for growing these crops. Biodiesel is chemically formed by reacting alcohol with vegetable oils to produce a chemical compound known as ester. These esters, when used as fuels, are known as biodiesel. The chemical process by which biodiesel or esters are produced is known as trans-esterification. Thus, trans-esterification of vegetable oils, animal fats, or waste cooking oils is the process behind conventional biodiesel.
Biodiesel process basically is a trans-esterification process in which any vegetable oil containing triglyceride is converted into biodiesel, which is actually FAME, fatty acid methyl ester. So it's a one-step process, and in this process vegetable oil plus methanol and catalyst is added. As such, in the conventional process, this process is carried out at high temperature at the boiling point of methanol. But in our process, IIP process, we add a patented solvent, and there is as such no heating is required. Only mild stirring up to 1 to 2 or 3 minutes is required.
Oil can be extracted from a variety of plants and oil seeds, but only those plant sources can be used for biodiesel production in India which are not used for edible oils and which can be grown on large scale in wastelands. Plants like Jethropa, Karanjia and rice bran are some of the options available. Of all the plant candidates as biodiesel yielding sources, Jethropa curcas stands as the best choice. The fact that Jethropa can be grown in any wasteland with less irrigation gives it a distinct advantage for consideration as the prime biodiesel feedstock in Indian conditions. 1 hectare of Jethropa plantation with 4,400 plants in rain-fed conditions can yield about 1,500 litres of oil. It is estimated that about 3 million hectares of plantation is required to produce oil for 10% replacement of petrodiesel in the country. Waste animal fats and used frying oil, also known as fellow grease like peanuts, cottonseed, sunflower seeds and canola, are some of the potential feedstocks for biodiesel. Esters made from these products can be used successfully as automotive fuel. The most common blend is B20, a mix of 20% biodiesel with 80% petroleum or diesel. Biodiesel has 11% oxygen by weight and essentially contains no sulfur, which means less pollution. Moreover, production of biodiesel, unlike petroleum or diesel, is relatively a simple process, and therefore large-scale production can be undertaken within a short period of time. The use of biodiesel in a conventional diesel engine results in substantial reduction of unburned hydrocarbons, carbon monoxide, and particulate matter. Biodiesel decreases the solid carbon content of particulate matter because enough oxygen in the fuel enables more complete combustion to CO2. With the result, biodiesel produces some 80% less carbon dioxide and almost 100% less sulfur dioxide compared to conventional diesel. Biodiesel is the only alternative fuel that runs in the conventional diesel engines without the need of modifying them. Hence, no change is needed in refueling infrastructure as well as spare part inventories. Moreover, biodiesel fuel is non-toxic and biodegradable as well.
Biodiesel doesn't contain any sulfur, so for BS4 or BS6 there is an issue for sulfur. It should be less than 50 ppm. So as such, biodiesel doesn't contain sulfur, so it will not affect the pollution. It will decrease the pollution norms, as well as it will more friendly than engine part. As such, biodiesel also contains oxygen, so complete combustion of engine is there if biodiesel is used. Actually, biodiesel, as I told, is derived from bioresources. So if we blend up to B20%, means B20 means biodiesel 20 and diesel 80%. So automatically most of the vehicles which comes under the BS3 or BS4, they may automatically upgrade it up to BS5 or BS6 grade.
The cetane rating or number of biodiesel is also higher than that of conventional diesel fuel. Cetane is a measurement of the quality or performance of diesel fuel. It provides information about the ignition delay, that is, the speed of self-ignition of diesel fuel when injected into hot air through the fuel injector of an engine. Diesel fuels with higher cetane ratings have shorter ignition delays, providing more complete combustion and allowing engines to operate more effectively. The higher the cetane number, the better the fuel burns within the engine of a vehicle. The National Biofuel Mission has laid special focus on phased expansion of areas under biofuel feedstock crops like Jethropa, Pongamia, etc. It has included several small missions covering promotion of large-scale plantation of feedstock crops in forests and wastelands, procurement of seeds, and oil extraction, blending, trade and research and development.
As far as energy security or economics is concerned, if we can save up to certain extent in the foreign exchange, as we have to pay the crude oil price which we used to brought from different countries, so we have to pay in dollars or foreign exchange. So as such, if we can prepare up to 3 or 5% blend, means 5 million ton, if we are ready to prepare biodiesel or diesel from our own resources, we can save a lot of foreign exchange, and that money can be used for other source of funding and for the employment and all those things.
The aviation industry plays a key role in the global economy, serving as a crucial backbone for millions of jobs worldwide and contributing about $2.2 trillion in the global GDP. By 2035, the Air Transport Action Group (ATAG) expects 7.2 billion passengers will be served by the airline industry, which is twice the number of passengers in 2016. India's aviation sector has also been expanding to keep up with the rising demand for air travel, which is now one of the world's fastest growing markets. With the result, aviation fuel has been witnessing one of the highest rates of growth among all petroleum products in India. The environmental concerns resulting from continued dependence on petroleum-derived jet fuel have spurred international efforts in the aviation sector towards alternative solutions. Keeping in view climate change-related concerns, the International Civil Aviation Organization adopted a global scheme in October 2016. The Carbon Offsetting and Reduction Scheme for International Aviation is a carbon offset and carbon reduction scheme for airlines to lower CO2 emissions for international flights and thus curb the aviation impact on climate change. The scheme is voluntary for all the countries till 2027, after which it would be mandatory for every international airline to follow it. This step has resulted in renewed interest and demand from the aviation industry to incorporate renewable energy sources such as biojet fuel.
CSIR, which is a carbon offsetting scheme where it is actually a mathematical formula where it is calculating the amount of CO2 produced by any aircraft. So if it is offsetting by it, you need to use some bioaviation fuel or pay tax. So in terms of if you have an indigenously developed plant where you are producing continuously bioaviation fuel, so in that terms it has very huge potential in terms of CSIR, because right now it's a voluntary period, but from 2021 to 2026 it is going to be implemented on compulsory basis, where either you have to pay carbon offsetting tax or you have to use bioaviation fuel.
Towards this end, scientists at CSIR's Indian Institute of Petroleum have developed indigenous processes for the production of renewable green aviation fuel from non-edible oils and waste oils as well. The demonstration plant is based on a patented catalyst and process known as biojet process and produces bioaviation fuel which is more energy efficient, economical and environmentally friendly. Till May 2021, CSIR IIP has produced approximately 9,500 litres of bioaviation fuel. This indigenously developed biojet fuel process by CSIR IIP is called DILSAF, which stands for Drop-in Liquid Sustainable Aviation and Automotive Fuel Process. The main ingredients used are non-edible oils such as Jatropha, used cooking oil and waste oil from the palm refining industry. These are converted into aviation fuel.
In terms of origin, yes, it is different from normal aviation fuel. In terms of identity, it is identical to your normal aviation fuel. That's why we call it drop-in. So that's why our process is called DILSAF, Drop-in Liquid Sustainable Aviation and Automotive Fuel. Unless you don't do carbon dating, you will not come to know whether this aviation fuel has come from vegetable oil source or from the normal crude based source. So in terms of product property, it is similar to normal aviation fuel.
In the first step of this process, impurities such as metals and solid contaminants present in the oil are removed. Then this oil is pumped using a high pressure liquid pump which is mixed with compressed hydrogen. This mixed feed of oil and hydrogen is sent to the reactor. The reactor is maintained at high temperature and high pressure conditions. The reactor is packed with indigenously developed CSIR IIP catalysts. The catalyst converts the triglycerides present in the oil into hydrocarbons, water and carbon dioxide in the hydrogen atmosphere. The unused hydrogen is recycled back for reuse in the pressure swing absorption unit. The hydrocarbon product is then distilled into naphtha, kerosene and diesel. The biojet component is further analyzed for different specifications. This fuel was supplied to SpiceJet Airlines, which tested India's first biofuel flight from Dehradun to Delhi on August 27, 2018. Another milestone was achieved when the Indian Air Force AN-32 aircraft used a 10% blend of Indian biojet fuel to take off from Leh's Kushok Bakula Rinpoche Airport on January 31, 2020. This was the first time that this mix was used in both engines of an aircraft. This fuel is made from Jethropa oil sourced from Chhattisgarh Biodiesel Development Authority and then processed using IIP's technology.
We have used this fuel in actual commercial plant where we use 25% of this fuel into actual SpiceJet aircraft where it has been shown in the data from the flight figure shows that the efficiency is slightly higher. Moreover, the engine temperature was slightly lower, means that the engine heating was lesser compared to normal crude-based aviation fuel. Moreover, we have also used this fuel for AN-32 aircraft. In 26 January 2019, this fuel was used in 10% blend for Republic Day fly past ceremony. Again, this fuel was used in one of the AN-32 aircraft where it landed at very high altitude at Leh airport. So this fuel has already shown a lot of potential in terms of its usability. Right now we are looking forward for its commercial usage.
Every year, India imports helium gas worth 55,000 crores or nearly $8 billion, primarily from the United States. To start the production of helium in India and reduce our dependency on imports, scientists at the Indian Institute of Petroleum have developed a helium extraction method from oil fields where gas is a byproduct. But why is helium so important? Due to the stable nature of helium, even at extremely high temperatures and its high thermal conductivity, it finds usage in a number of manufacturing processes. With India's focus on Make in India, the demand for helium will continue to grow as more global companies set up their production base here. The applications of helium are diverse and range from nuclear power plants to virtually every modern electronic item which requires semiconductor chips, such as smartphones, televisions, laptops. Helium is also an important refrigerant for superconducting magnets. It finds applications in magnetic resonance imaging or MRI scans as well. Global helium demand is increasing day by day, especially due to rising demands from developing countries. So it's important for India to develop its own production capacities. Helium is a chemical element with the symbol He and atomic number 2. It is a colorless, odorless, tasteless, non-toxic, inert, monatomic gas. The first in the noble gas group in the periodic table. Its boiling point is the lowest among all elements. Helium is an inert gas and thus doesn't react with other elements. Helium is conventionally derived from petroleum gas fields. Nearly 90% of the world's helium deposits are in Middle Eastern regions of the United States of America. India is yet to discover large natural gas deposits. Therefore, it's imperative to look for unconventional terrestrial sources such as thermal springs and monazite sands. Due to the high cost and energy-intensive nature of cryogenic distillation, which is the predominant method used to extract helium, Indian scientists at IIP Dehradun have developed an indigenous technology for recovery of helium from natural gas. The process is called cryogenic PSA hybrid absorption process for the recovery of grade A helium natural gas. CSIR's Indian Institute of Petroleum in Dehradun is one of India's finest research and development institutions in the field of petroleum and energy. In the years to come, IIP's role will become even more important as it works to develop alternative energy technologies to reduce India's petroleum imports and replace it with indigenous materials and technologies. Innovations in critical areas like biofuels, biofuel producing technologies and helium extraction will not only lessen our dependence on imports for these commodities but would also bring down carbon emissions. The expertise and knowledge base developed would in turn contribute significantly in achieving the country's mission of an Atmanirbhar Bharat.